Hi folks, I'm Shahidh. I'm going to be talking about building backends in Redux style with GraphQL and serverless. So I think we have had a lot of GraphQL talks already. So sorry to break it to you, it's going to be more GraphQL talks. So I work at a company called Hasura. We are an open source company focusing on GraphQL solutions on top of Postgres. It basically converts your DB into an API that you can use from any kind of client applications. There's a lot of fancy stuff like remote joins and actions and all. Just do look it up. You'll find more stuff online. So Redux is awesome, right? Who here doesn't like Redux? Like, I hate Redux. Maybe you can go have a coffee and come back while I keep talking about Redux. No, just joking. Cool. So Redux introduced this way of building UIs. Oh, I'm not full screen, huh? So you can just, yeah, that's better. So you have you have to manage your state on the UI. So you have some component with some state on it. You change something or do something on the UI that dispatches an action. And then that action is bound to a reducer. Now this reducer function, like a pure function, will execute. That mutates the state again, updates the state again. And that will come back, and whatever components are subscribed to this part of the state will come back and update. The components will refresh, right? So this is a nice pattern of doing things in which you have like a clean abstraction. Everything is separate. Everything is declarative. There's a little bit of boilerplate code involved to get this done, but once you have it, it's a very easy way to manage your UI components. What else is awesome? Like serverless is awesome, right? Anybody doesn't agree? No? So with serverless, you can do things like this. You just write a function, and then you have a CLI command, or you just put it on a browser UI, and then you get an HTTP endpoint. You can curl that endpoint, you get response from that function, whatever function you wrote. And obviously, what else is awesome? GraphQL, right? So GraphQL introduced a way of querying things in a graph manner. I mean, not particularly, but somewhat like that. So typically in your REST API, you have these different endpoints. Now you have one endpoint. You make queries to this one endpoint, and everything else just works the same way. So how many of you have deployed or used a serverless function? Okay, quite some. How many of you have already worked with GraphQL in some manner? Okay, that's a lot. Cool. So I need to go much more detailed into that. So what's next? So now let's try to take a look at this in the GraphQL serverless landscape, how your Redux model translates. So you have a UI. The UI, some action on the UI resulted in a GraphQL mutation, similar to your action that was dispatched. Now that GraphQL mutation triggered a serverless function. Now this is more like your reducer function. It does some logic, business logic. That will come back and update certain state. And that state is passed down to the client using GraphQL subscriptions or live queries. Now it will update some certain UI components. So now this is your state on the UI, and this is your state on the backend. So the backend part is what I'm going to be focusing a little bit on today. And to do that, to demonstrate that, I'm going to build a demo application, app that will just sanitize text or filter bad words. So to do that, I am going to mirror my display. Now I have no idea what happened. Let's see. Okay. Nope. Okay. Let's see. Yes, I got it. Oh yeah. So I have create React app one folder here. I've already done npm install so that we don't have to wait forever for this conference to get over. So I am just going to do npm start here. So it's going to start the application. Now let's see. Okay, something is happening. Standard React boilerplate, right? So now let's get into the code. So new tab. Everybody is on Visual Studio Code. So why not? I'm also going to use Visual Studio Code. So first thing, I don't know if you do this, but this is the first thing I do. Get rid of that. I mean, I know it's supposed to help you while you go into production, but during development, that's like a pain. Okay, so the first thing I do is, so I've already installed certain NPM dependencies, which helps me work with React and GraphQL and stuff like that. So before I get into my front-end code, I need a backend, right? So let's see what backend I can use. So what I'm going to do is, this is what I'm going to be doing. I'm going to create a UI in which you can type certain text, which might have some swear words or some what you call bad words. That will execute a GraphQL mutation on the backend. Here we are using Hasura with Postgres. Hey, surprise. And that will execute a serverless function which is running on glitch. Heard of glitch? Okay. It will in turn update the DB back. That will trigger a subscription. And that will come back and update the UI again with the clean content. So this fits into the Redux model that we have been seeing, right? So let's get that backend started first. So let's look at what's the top deployed app on Heroku. Hey, again, surprise. So I've deployed this app already. It's just you click here and click one more button and you're done. So then you get this nice console where you can do a lot of GraphQL things. So what I'm going to do is create a table. My table is called tweets. So I'm going to be focusing on tweets, and I'm going to create an ID column. I'm going to create a raw tweet, which is text, and then a sanitized field, which is going to be text again, but it's going to be empty in the beginning, so it's nullable. So that's all I have to do. I have created my table. Hey, suddenly I have my GraphQL API ready. So let's see what tweets I have. I have no tweets, I guess. Yeah, no tweets. So let's create a tweet. So I will do insert tweet. I will say, hi React India. And I will say, I'll say, give me the ID, the row, and the sanitized. Okay, I need to get rid of this guy first, this one first. So let's see. So I made a mutation. My data is entered into the DB. I don't have anything sanitized yet. So now let's do this from the UI, right? It should be super simple. So let's try it out. So first I need to set up wire my React application with my GraphQL backend. So I'm going to import some stuff. Apollo provider, yada yada, and then I'm going to create Apollo client. So this is how I'll create my client. I'm going to change this URL to what I'm using now, dangerous tweets. So let me make sure that's correct. That looks correct. And then I'm going to just wrap my app component with the Apollo provider. So client is client and app. That's it. My app is wired up. Now I need to create my UI. So I'm going to create a component called dangerously tweet. I haven't looked at how this will look in the screen. Okay. Is it big enough? Maybe one more size. So here I will have to import some more stuff. If you see here, I'm going to be using React hooks. Everywhere people are using hooks nowadays, so why not? And I'll create the component. So this is my component. And inside the component, I need an input. So I'll create the input. And then I will need to use the mutation. So this is how I will use the mutation, but I don't have the mutation defined. So let's define that. So I'm going to be a little bit, I'm going to cheat a little bit in a way that I've defined snippets for everything. So it's easy that I don't have to type. So this is my mutation, insert tweets, objects, raw, dot text, returning an ID. So this is very similar to what we have done here. I'm just using a GraphQL variable so that my text of the tweet can come from the input box. So once I have that, I need a form to show on the UI. So I have a form with a text area. I have a button which will submit the tweet. So this is like dispatching your action that will execute the mutation. So here I'm calling the add tweet function returned by the hook, and then I'm giving it the the variable. So a little bit more boilerplate code or some error handling. Let's see. Yeah, so this should do it. So if I'm handling some error state, loading state, and something similar. So now let's wire up this dangerously tweet component into our UI. So I'm going to get rid of all these things. So I'm going to say import dangerously tweet from dangerously tweet, and then just going to use it here. Okay, let's go back and look at our React app. Yes, I have a text box and I have a button. So now let's try something. Let's do this and make sure that our mutation is getting executed. So it's executing, it's dispatched, right? Now let me go back and see if it is there. So if I go to data, my tweets, yes. So both the tweets that I made are here, but sanitized is still null because we haven't set up a reducer function yet. So let's see how to do that. Let's see how to set up a reducer function. So I have this glitch project open. So I'm going to be using some ML and the AI. So you'll see what it really means in a while. So here it's just an Express app which is going to be receiving events from my backend. So whenever I create a tweet, it's going to receive a API call, a webhook event. So from the event, I need to get the state. So I'm going to do const state event.new. I don't know. Event.data.new. Yeah. Data.new. And then from this, I will get the row, state.row. And now here is the magic. I will have sanitized filter.clean row. What an amazing function, right? Has anybody looked into the source code of this library, bad words? It's just a huge JSON file with a lot of regex matching. So that's the ML and the AI we are going to be using. So we have cleaned it, and now let me get rid of the return function. I will uncomment some code, again using my own project, GraphQL. I'm going to be executing this mutation from within my reducer function. And what that is going to do is, it is going to go and update my DB, dangerous tweets. So from the event data, I'm going to get the ID. So where is the ID coming from? So event.data.new.id, and it is going to update the object, the object in the DB with the sanitized version of it. Okay, so this is live. So glitch autosaves apparently. Like every time I press Ctrl S, it's like, why are you pressing Ctrl S? So I'm going to copy this. So now the next step is for me to set up my reducer. So I'll go to events, and I will say create. So I'll call it sanitize, and I will choose my tweets table, and I will say trigger this on an insert operation and trigger this URL. So I'm done. So now let's try to create a tweet from our app again. So refresh. So let's see. Hell yeah. Or not that, maybe, probably. So yeah, most of the bad words are swear words. I can't use the A word, the B word, the C word, the D word, the F word. I can't really use any of them on stage. So this is okay apparently. So Is hell good? Does anybody know the answer? No? So it's dispatched. So our reducer might have done its job. So let's see. Invocation logs. Yes, something has happened. And the request has gone. Some response has come back. So let's look at our data. And yes, the word hell is gone now, right? So fancy. Everything is happening in the DB. We can see that in our admin UI, but React apps need some more love. So let's create a component which will let us get this updated state. So I'm going to create a new component called tweet status. So again, import some more stuff. And let's see. Now I need to create the subscription. Yes, the tweet status subscription. Now I don't know what the snippet for that is. Subscription. Okay, I'm just going to write it. So tweet status. So I want to get the status of the tweet. So I'm going to wrap it in a tag called GQL. And inside it, I'm going to write subscription. Oops, lot of typos today. Okay. Tweet status. I will define an ID. I need to give what ID I need to get the status for. And here I will see
like your audio.
Tweets where
some track that you can
ID equals
No, I mean like that.
dollar ID.
Will it be like
Let's see. And I want to get back
so
the
it's not
ID
like, it's just example.
and the sanitized version. So
Okay.
you'll see how it's auto-completing all of these things, right? Okay, now it says some error, expected name. Okay, I forgot a bracket. So what is this? Yeah. So if I did something else, ABCD, it will say ABCD is not found here because I've configured my Apollo client, the VS Code extension to contact my server and introspect. And so you get like runtime validation in the IDE. So I have my subscription ready. Now what this is going to do is it's going to get the ID and the sanitized text for the given particular ID. So let's see. Now I need to create this component. And here what I'll do is use subscription. So I have a hook again. So again some more boilerplate code where I will say if there is a loading, say loading. If there is an error, print the error. If there is if I don't have a data key like this, and if I don't have the sanitized tweet yet, show some GIF, and then if I have the sanitized GIF, show a sanitized tweet, show another GIF. So that's it. Our component is ready. Now let me just remove this dispatched and use the tweet status here. So tweet status ID equal to data.insert tweets.returning of 0.id. Yep. So this should do it. Let's try. Let's try this out. Oh, okay, that worked. But our ML and the AI needs a real world test, right? So where do I go for some really nice tweets? Yeah, Ken Wheeler. So I found a Ken Wheeler tweet that I can actually use. So let's see if how this works. So this is a Ken Wheeler tweet that I can actually use at a conference. So now I'm hungry. Yeah. So let's try this out. Okay. So let's see. I wish what would happen if Ken Wheeler had this application, right? Every time he wants to tweet something, he puts it here and it spits out this, and he's like an angel now suddenly. Everybody likes him. So that's the application. That's the demo. So we have seen like within maybe like there's 40 lines of code here, 35 lines of 38 lines of code here. So maybe probably within 100 lines of code, anybody with React skills and a little bit of JavaScript, I mean, of course you have JavaScript skills if you have React skills, suddenly any front-end developer can become a full stack developer, right? So you get to build applications in this manner, and it's a really promising thing where you can apply your concepts that you have learned while doing your front-end development into the back-end side of things also. So we are past this. Yes, the demo goals are with me today. So why don't we try something complex? Like this is a very simple thing, right? So pull out your phones, scan this QR code. So this is like a food ordering app that you can use, and this is some demo that I do every time. So you can go to the URL or scan the QR code, and it will give you a UI where you can place orders for certain items. So now as soon as you start making the orders, it will show up in a common place here. So let's see, maybe you want more time to see the QR code. Okay. Oh, yeah. So somebody is placing order. So I'll also make an order from my side. So if I place a new order and I choose some items, I get these 4 steps. And these 4 steps are like 4 different states of my, or 4 different keys in the state of my application. And each of them triggers a serverless function. Like when order gets created, it triggers the validate function. When the payment, and that will say that, okay, it's ready for payment. And I think I should just show this like this. So this is what is happening. You have a new order, and it creates the state, and then that will trigger this reducer function, which will validate the order. And this chain continues until all the steps are complete and the order is completed. So that is what is happening here. A lot of people are placing orders, and then each of the function is getting executed, and as soon as one step completes, the next step is also executed. It's basically chaining all these functions. So a lot of people have placed orders but haven't paid yet, like me. So I'm going to make the payment, and it will go through. So and this is like very scalable, like using serverless functions in the back end. Like when I'm doing this demo, I'm paying for those functions runtime, and when I'm not doing the demo, I'm not paying anything. Similarly, if you run a company based on such an architecture, you are only paying when somebody is doing something on your application, right? And you have this cloud provider backed scalability that is baked into this, and it is super easy for you to go from 0 to like managing 10,000 orders or 1 million orders. Like we started from 20 and we have like 110 right now. So it's super awesome that you can apply a certain kind of pattern and then just suddenly become super scalable and then get all the monies and then like buy an island or whatever. So I'm going to show one more demo in which the resiliency of this is shown. So this is using AWS Lambda functions on the backend. So I'm going to show you what will happen if one of the function was down or somebody just from AWS just decided to pull the LAN cable from the box. I mean, of course it doesn't happen, but so somebody made an order. I ordered 10,000 times. I ordered 1,000 times the same order. So now suddenly 1,000 orders are created, and you will see how each of them are getting validated and payments are getting done. And in between, what I'm going to do, Oops. Okay, that was not expected. Yeah, there we go again. So orders are getting validated and things are happening really smooth, but then somebody decided to go into the AWS console and disable one of the functions. So one of them was throttled, and let's see what happens if a function is throttled. So things were happening till this is the function which was throttled. So when it hit here, it couldn't continue anymore. So none of those function was getting executed, and anything that got validated or got restaurant approval got completed till that point. But after that, nothing was happening. Now, let's say this is like a scenario in which one of your function had a bug in the code, a deployment caused a disruption. None of that matters now, because as soon as it's fixed, it will resume from wherever it was stopped. So everybody's order was baited restaurant approval, and as soon as you enable the function back or you fix the problem, the system will just pick it up from where it was left. So as soon as you like save it, recreate it, it's gonna pick up and then complete the orders to the finishing point. So by following this architecture, you immediately get high developer velocity, you get scalability, you get resiliency. So by putting together these nice technologies together, it's pretty amazing that what a front-end developer can do even without any of the infrastructure or backend or DevOps skills. So that's pretty much my talk. Thank you for listening, and I hope you had a good time with the demo. But yeah, Nader has set the bar so high, I couldn't even come close, I'd say. Anyway, so we are an open source company, so find us on GitHub, start the project, and follow me on Twitter. The entire application code is available on GitHub. The link is here. Go look at the code, fork it, remix it, do whatever you like. And then I have some stickers. You would have seen some cool graphics. I have some stickers with me. Find me, Vlad or Praveen or anybody else here wearing the Asura t-shirts, and you'll get some stickers. Thank you. Thanks a lot. Thanks for having me.
Recording was brought to you by Twilio. We allow you to integrate different means of communication such as video, chat, or SMS into your React applications. If you want to learn how you can send SMS directly from a React chat, check out this video on the right or go to our Twilio YouTube channel. And if you want to watch another React India talk, we picked one out just for you over here on the left. Thanks for watching.